Hey guys, good morning. It's Mr. Muscato with you. Hope you guys are enjoying the snow. All right, so this morning what we're going to take a look at is arithmetic sequences. All right, so I guess the first thing we have to ask ourselves is what is a sequence? Right, so a sequence is a series of values that follow some rule. Right, so for example, I could have a series of values that does something like this, right? So I have a 6, I have a 9, I have a 12, I have a 15, I have an 18, right? And so on and so forth, right? So anytime that a series continues, um, we use three little dots. Those are called ellipses. All right, so that means that that sequence runs on forever towards the right. Okay, so that's one series. All right, another series could be something like 2, 4, 8, 16, 32, right, 64, right, dot, 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 ellipse, right? All right, so these are two sequences, right? So a sequence, again, is a series of numbers that follows some rule, right? So in our first sequence, to get from one term to another, the rule is that we are adding 3. Okay, so between a 6 and a 9, we're adding 3. Between a 9 and a 12, we're adding 3. Between a 12 and a 15, we're adding 3, etc. Right? So the rule there is that we start at the value 6 and then we add 3 to each subsequent uh, value in our sequence. Okay, so this is, let's call this sequence 1, all right, S1. The sequence below, right, is a little bit different. Okay. This one, what do you think the rule is? Well, the rule is that from the first sequence, so we're starting at the value of 2, and then each number in the sequence is basically the previous number doubled, right? So what we're doing here is we are multiplying by 2, right, to get to the next value. Right? So from 2 to 4, we multiply by 2. From 4 to 8, we multiply by 2. All right, so this is a different kind of sequence. All right, because we're multiplying instead of adding. All right, then there are other sequences that follow, other rules. Right, so let's call S3. Okay, and in this one, let's say that we have something that looks like this. Right, so we start off with the value 2, the next value is 3, the next value is 5, the next value is 8, the next value is 12, right? And so on and so forth. All right, so this one's a little different too. All right, we start at the value 2, all right, and we add 1 to get to the next value, and then we add 2 to get to the next value, and then we add 3 to get to the next value, and then 4, right? Um, and it would follow, logically that, the next value in our sequence would be 17 because it would be plus 5, and then the next value after that would be 23 because it would be plus 6, etc. All right, so those are sequences. There's all different kinds of sequences. All right, some are called geometric sequences. Some are called, just other different kinds of sequences. Nothing. I can't think of any right now off the top of my head, other than arithmetic sequences and geometric sequences, because it is a little bit early in the morning still, and my coffee hasn't kicked in. But that's okay, right? We're only really concerned with arithmetic sequences right now. All right, so the next question is then what is an arithmetic sequence? How can we tell whether or not we have an arithmetic sequence? All right, well, arithmetic sequences have a constant difference between terms. All right, so in other words, to get from one value in my sequence to the next value in the sequence, right, I'm going to have some difference. And then to get to the next one after that, I'm going to have the same difference. All right, so let's take a look at our first three differences, or our first three sequences, and see if we can determine whether any of them are arithmetic sequences. All right, So going back to sequence 1, all right, so we're looking at this one, all right, we start at the value 6, and the next value is 9, the next value is 12, and 15, etc. All right, so we had determined that the rate of change, or the difference, okay, the difference between our terms, right, is plus 3. And that follows, right, all the way down the sequence, right? This is plus 3, this is plus 3, this is plus 3, right? And so on and so forth, right? Between 15 and 18 is plus 3. And it's only a logical conclusion there that, you know, the next term would be 21 and the next one would be 24, et cetera, et cetera. All right, so this tells me that I have an arithmetic sequence. Arithmetic. Okay, sequence. The rate of change, all right, between terms is the same all the way down the line. Okay, this is also called, sometimes it's called a linear sequence. Okay, think about, right, just kind of keep in the back of your mind, a slope, okay, on for a linear function. All right, how do we know that a slope, or how do we know that a graph is linear? Well, the slope between points, one of the ways we can tell, right, is that the slope between points, all right, is constant all the way down the line. Well, if my rate of change is in this case plus 3 the whole way, all right, well, there's my slope, right? I have a slope of 3, right? I move up 3 and over 1 every time that I'm adding a new point. All right, so just keep that concept in the back of your mind, and it might make visualizing these things a little bit different. A little bit later on, too, we're going to take a look at how to graph these things. All right, let's take a look at sequence 2. Let's determine if this is a linear sequence or an arithmetic sequence, right? Well, to get from one term to the next, I have a plus 2, or I'm sorry, a times 2, right? From 2 to 4 is multiplied by 2. From 4 to 8 is multiplied by 2. From 8 to 16, it's multiplied by 2. So I'm basically doubling the last value to get the next value. All right, so even though this looks like a constant, it really is not. Okay, so yes, we're multiplying by a constant. We're multiplying by 2 all the way down, but the difference is not constant. All right, so if we look at the difference in terms of addition or subtraction, right? Well, what do we have? Between 2 and 4, we are plus 2. Between 4 and 8, we are plus 4. Between 8 and 16, we are plus 8. Between 16 and 32, we are plus 16, right? So this does not follow a constant difference, all right? We have an increasing difference, okay? So this is a different kind of sequence, all right? We're going to look at these kinds of sequences a little bit further down the line, all right? But for right now, this is a non-linear sequence. If we were to plot these points on a graph, we would not get a line. All right, we would get some kind of a parabola. We get some kind of an arc. Okay, so this is nonlinear. All right, non-arithmetic. Okay. All right. What about the last one? All right, so we're not multiplying anything here, but again, the difference. All right, the difference here changes between terms. To get from the first term to the second term, I add 1. To get from the 3 to the 5, I add 2. To get from the 5 to the 8, I add 3, right? So that is nonlinear as well. This is non-arithmetic as well. All right, so for us to determine whether or not a sequence is arithmetic or not, right? We have to look at the rate of change. Okay, is the difference between terms constant? All right, that's what we're looking at. All right, so let's look at a couple of other sequences. Right, let's say that I have a sequence here, and it starts off at let's start it at 1. Okay, and then the next value is 3/2, and then the next value would be 2, and then the next value after that would be 5/2, and then the next value after that would be 3, right? And then the next value after that would be 7 halves, right? And then the next value would be 4, etc. Okay? So is this an arithmetic sequence? Yes or no, right? So pause the video for a second. All right, take a moment to look at this, and then you tell me: is this an arithmetic sequence or isn't it? All right, so pause the video real quick and take a look at it, and then come back. All right, so what do you think? All right, so was it arithmetic or not? All right. Okay, so let's take a look. All right, so what's the difference between the first and the second term? Well, I'm increasing here by plus 1/2. Okay, because 3 halves is also, right, we can also write that as 1.5. Okay, so we're increasing by 1/2 or 0.5. All right, to get from 3 halves to 2, I'm increasing by 1/2. Okay, right, because 1.5 to 2 is the difference of 1/2. All right, from 2, right, well, 5 halves is 2.5, right? So we're increasing by 1/2. Okay, from 5 halves to 3, we're increasing by 1/2. All right, and so on down the line. So this is, all right, an arithmetic sequence. Yes. Okay, arithmetic sequence. Okay, because we are increasing by a constant rate of change. Okay, let's talk about this next sequence. All right. What about this one? Let's see if this one is an arithmetic sequence, right? So I'm going to start at the value 12, and I am going to go to 7, and then I'm going to go to 2, and then I'm going to go to -3, and then I'm going to go to -8, and I'm going to go to -13. All right. So take a look at this sequence, all right, and tell me, is it arithmetic or not? All right, so pause the video real quick, take a look at it, and you tell me, is it arithmetic? All right, so what'd you come up with? All right, is it arithmetic or not? All right, okay, well, let's take a look. All right, my first term is 12. To get to the next term, I subtract 5. Okay, from 7 to 2, I subtract 5. From 2 to -3, I subtract 5. From -3 to -8, I subtract 5. Okay, and so on down the line. So yes, this is also an arithmetic sequence. All right, so even though even though the difference is negative in this case, okay, we're still basically drawing a line. Right, my slope is, in this case, it's negative. It's -5. Okay, I'm still describing a linear progression, all right, between values. All right, so yeah, this is an arithmetic sequence, right? So it doesn't matter if the difference is positive or negative, we are describing a line, okay? Because the rate of change is constant, all right? And that's what we're really looking at. What is the rate of change? Is it a constant value, yes or no? Okay. All right. So let's take a look at one more and see if we can determine whether or not it is an arithmetic sequence. All right. So I'm going to start at the value 12. All right. And then I'm going to go to 14. And then I'm going to go to 16. And then I'm going to go to 20. And then I'm going to go to 24. And then I'm going to go to 28. Okay. And then I'm going to go to 34. All right, and 40 and 46, all right, etc. All right, so we're going to take a look at this. All right, is this an arithmetic sequence? Yes or no? All right, so let's take a look at this one. Pause the video real quick. Take a look at it, and you tell me, is this an arithmetic sequence? All right, so what do you think? All right, well, let's take a look at it, right? So between 12 and 14, I'm increasing by 2. And between 14 and 16, I'm increasing by 2. All right. So that looks linear so far. All right. But then between 16 and 20, I'm increasing by 4. And then between 20 and 24, I'm increasing by 4. So right there, right, I know that something is up, right? This is not a constant rate of change. Okay. This is plus 4 here, and then we jump up to a plus 6 and a plus 6. All right, and so on and so forth. So even though some of the terms in the in my sequence have a constant change, not all of them do. All right, so it's these differences in the changes. All right, that tells me that no, okay, this is not okay, not an arithmetic sequence. All right, so there we go. All right, so at this point, excuse me, we have seen what a sequence is. All right, and we have taken a look at how um, arithmetic sequences work and how to identify arithmetic sequences. All right, so we'll get started on that. In the next video, what we're going to take a look at is how to describe mathematically with an equation an arithmetic sequence. All right, so take a break, go get yourself some hot cocoa or something, have a little breakfast. All right, and then come back and we'll talk about how to describe mathematically an arithmetic sequence. All right, we'll see you in the next video.